Today we're dealing with inductive and deductive reasoning, and in some of our lessons we've talked a little about this, maybe not calling it that. We have talked about truth value, which we also touch on today. But to begin with, I want you to take a look in your student journals, page 39, and I want you to work with your groupies right now, and go ahead and complete exploration 1. Okay? We're going to take a couple minutes and work on that. Do your best. They're kind of... Well, you got to read the directions. Okay? Just so you know, a conjecture is an unproven statement based on observations. So we're going to use that. We're going to use reasoning today to help us to solve these problems. So look at your examples and try to come up with the next 3 objects, which will give you the 10th object in the pattern. Okay? You can draw it, yeah. Yep. Okay, I would, after you draw it, then write down, like explain in words what you, how come, or how you knew that. Okay, what the actual pattern is. Okay, but draw it and then write down in words how you know what the pattern is.
These have flimsy pages.
I know, very cool, huh?
Them like,
Okay, okay. Hey, what happens in letter A? Drew. Circle moves in the triangle. So where's it going to be next? So down here? Okay. Where would it be after that? Okay, so what's happening? Like, how do you know that? Everyone see that? Right, left, up, right, left, up. So right, left, up. So this one is going to be? Right. Hey, that's right. All right. Alex.
So for explanation, you just say that circles move clockwise?
Yeah, you could say the circle's moving clockwise direction in the corner. Yeah. Yeah. How many, so like, how would you say that? Okay. Good. Everyone see that? So she's looking at the sequence saying, hey, that's the same as that, which means that one's going to be the same. Another way to go about it, yeah. Okay? So you could say the circle, your conjecture could be the circle is rotating clockwise in a clockwise direction to the next vertex. You could talk about the sequence. 1 and 4 and 7 are the same. Therefore, every third is going to be the same, meaning 10 is going to be the same as well. Okay? Nathan? Yeah, for B. Go ahead. Okay, so it's moving clockwise. So there's a few things going, right? Like here we're that. So we're there, there, there. So maybe counterclockwise, or excuse me, clockwise, but we're dealing with like different looks of the line too, right? So what you're saying, it's moving clockwise, so you know the next one's going to be up here somewhere in this quadrant. Okay, and then the next one. So if we look at those, the next one's going to be in this quadrant, and then that quadrant. Everyone agree? Okay. So now we just need to figure out what goes in those quadrants. Any ideas? Alex?
So on it, so as you said, it is one clockwise, right?
Mm-hmm.
But also notice that the bottom right and the top left are always straight.
Okay.
And then the top right and bottom left were bent.
All right, so we have straight lines in these quadrants. Okay? Meaning this one right here is going to be straight line. And this one is going to be straight line. The question is now, this one's bent. However, notice our bent lines It's hard to tell where they're going to. I mean, they're all bent different ways. True? Uh-huh. Okay. So you're thinking this one's going out because last time it went upward. Okay? So it's going, if you think of this going outward, this one's going down, this one's going up, this one's going out. So you're guessing this one's going up. Okay? Let's think about it as hugging the x or y axis. All right? So like this one would hug which axis? It's bending towards the x. So it's bending towards x. This one's bending towards y. This one's bending towards the y. This one's bending towards x. This one's bending towards. This one would be bending towards. What's our pattern? X, Y, Y, X. Think X or Y? Man, really tough to know what this one is. Can't figure it out?
Because you don't know if the first one in B is the first digit.
Okay, discuss it real quick. Let's figure out, let's come up with a common answer for that and why. Now talk with your groups about it real quick. Get about 30 seconds. Volunteer. Someone that hasn't participated yet. Anyone else give me some input on it? Ian? So you're saying it's going this way. Now I'm in pen. Now I can't change it. You better be right. I'm just joking. So, like why? Okay. Anyone else? The answer is right. Not so sure about the description yet. Okay, Maddie?
Well, I was thinking since they're not like numbered like in A, it could be X, X, Y, Y, X, X, Y, Y, because X, that one might be the third number of the sequence instead of just the first one.
Okay. Guys, let me do something here real quick. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Those are Roman numerals if you want like numbers. There's 3. Okay? All right. Now, when we're looking at that, the ones that are hugging the x-axis are in which quadrant? 1 and. So that one and this one. Okay? The ones that are hugging the y-axis are in which quadrant? That one goes in 3. How about this one? That's 1. Okay? So we never actually get to the 2 and 4. Right? So this guy right here, this guy is in quadrant 1. So in quadrant 1, we've got hugging x. Quadrant 3 is hugging y. Quadrant 1 is now hugging y. Quadrant 3 is now hugging x. So quadrant 1 now is going to hug. It's going to hug x because last time it hugged y. So that's where we're rotating. So look at this pattern there. Okay, and then it hugged y, and now it's going to hug x. Okay, Danica.
So I'm not sure if it's what you're trying to say, but I'm thinking that it's a pattern inside of a pattern where we have 1, 4, and 9, I think. 1 is pointing to, let's call it the right, and then number 4 is pointing up. So then, based on that very simple pattern, I'll say we can assume that 9 is going to be pointing to the right.
Good. So same idea. Yeah, pointing to the right, pointing up, so pointing to the right. This one's pointing down. This one's pointing to the left. The next one would be pointing down. Yeah. Jeremiah.
I think because I just looked at the squares in the first one, it's like in the top right, and the second one's in the bottom right, and then I just went around and so I knew it.
Okay. Good. That would work as well. All right. Hey, any questions there? I know they're kind of weird, right? It's a tough pattern. How about this one? Did anyone figure the pattern out there? Carlos?
So the way I described it was that the doubles alternate sides in a pattern of triangle, circle, square, and then for the opposite side, the other shapes follow the sequence of circle, square, triangle, square, circle, triangle, circle, square, triangle, circle, circle, triangle.
Okay, so you're saying 2 triangles, 2 circles, 2 squares. 2 triangles, 2 circles, 2 squares. 2 triangles. Okay? There, am I right?
Yeah.
Okay. So the next one would have 2 circles. And then 2. And then 2. Okay, did you guys come up with shapes that have 2 circles, 2 squares, 2 triangles in it?
Yeah.
Okay, so the point is now, where are they actually at? Okay, Hunter?
I noticed that like the square or the circle were not part of the doubles. They're on the circles on the top, the squares are on the bottom.
The circles were on the top, and the squares were on the bottom.
Unless they're like double.
Okay. Okay, so you're saying the circles are always on the top, squares are always on the bottom, unless they're part of a double. Okay? Danica? So you're looking at number, like, once again, sequence-wise. You're saying this one is identical to that one. Okay? And if we kind of keep with that, is this one identical to any other? Well, we don't know that for sure. We haven't seen it, right? Huh. Yeah.
2 and 5 are perpendicular, I think.
Are perpendicular. I don't know if they're called perpendicular, but that is a great observation. 2 and 5 are something.
Or opposite. Mirrored.
What do we call those? Opposites. Maddie, what did you just say?
Mirrored.
They're mirrors, which we call a reflection. This is a reflection of that one. Any other reflections? Nathan? 3 and 6. Those are reflections. Everyone see it? Yeah. Drew? 4 and 7 are reflections? They are. And 1. Those are all reflections. Every third is a reflection. Yes? Okay, so the next reflection would be our yellow, correct? So right here. And it would be a reflection of this, which is actually 2, which is where you were going, Danica. It's just we couldn't actually say that until we knew the pattern. Okay? And so there we've got that one, and then we're doing a reflection of 6, which is actually 3. So we'd have circle, triangle, square. Oops, that's an ugly square. And square. Unbelievable, my squares. Okay, and then a reflection of 4. So we'd have triangle, triangle, circle, square. Okay, really good. Okay, talking about their reflections of each other. Okay, that would be our conjecture. So you'd want to write that up. All right. Very good. Okay. Hey, really quick, I want to do one more piece here, exploration 2, and I want to do this together. Okay? It says work with partner. Our group is going to be our partner, our class. Use the Venn diagram to determine whether the statement is true or false. Justify your answer. Assume no region of the Venn diagram is empty. If an item in property B, if an item has property B, then it has property A. Quickly, tell your neighbor, is that true or false? If an item has property B, then it has property A.
Because property B is.
Okay, how many say true? How many say false? Okay, now let me look at this a different way. If an item, now let's actually think of property, your house. If your house is on the land you own, so if your house, or if property B is, if your house, or you are in your house, I guess, you're in here, okay, on this land you own, are you in property A? Yes. Therefore, if an item has property B, it automatically has to have A. Why? Because property B is included in property A. So this is
True.
This is true. True. Okay, it's true because property B is contained in property A. All right, now I want you to look at part B and answer that one with your groupie. Okay, how many say true? How many say false? If an item has property A, does it automatically have property B?
No.
Is there anywhere in this circle where property A exists but property B does not exist? Yes. And therefore, if an item is right here, it has property A, but it doesn't have property B. This is false. Okay? Property B does not include all of property A. Okay. Any questions there? If you want some more practice with it, you can continue the exploration on the next page. Okay? In fact, why don't you try C and D real quick, just to give yourself a little more practice. I think you guys are starting to get it. Give yourself a little more practice. How about C? If an item has property A, then it has property C.
False.
Yeah, if an item has property A, it doesn't necessarily have property C. Could it have C?
Yes.
Where would it have C at?
No.
In the middle, where they intersect. These are called Venn diagrams. Okay? Some items that have property A do not have B. True. Okay? How about if an item has C, then it does not have B? Are B and C, do they ever intersect?
No.
No. Therefore, if an item has C, can it have B?
No.
No, this is true. Okay, if some items have both A, or some items have both A and C, that is right here.
True.
And some items have both B and C.
False.
That is false. Okay. We got it?
Yeah.
Okay, I want you to turn the page in your journal, please. We're going to talk about conjectures and inductive reasoning. I want you to read through the definition of conjectures and inductive reasoning. This is page 41. Okay? Conjectures, inductive reasoning, then review what a counterexample is. We've talked about that a lot in here, but just read through it, make some notes to yourself. Okay, now that you've told your neighbor what conjecture means, hey, secret agent, take your earbud out. You guys, the reason I have to have silly example or silly rules is for people that will not remember on their own. So keep your earbuds out when I'm talking. Okay? A conjecture, you've told your neighbor what it means. Give them an actual example of when you could use a conjecture. Okay? Okay, give me an example. Something your neighbor told you. Yes?
Oh, me.
Go ahead, man.
Okay, so it says, a conjecture is an unproven statement based on observations. It's like, if I looked at her pen, I would observe that, her pencil, I would observe that it has like a red little thing, and I could say, all mechanical pencils have red on them, but that would not be true.
Very good, yeah. All right? All right, we won't go there. All right, another. Drew. What's that? Big bird? Bigfoot, is that a conjecture? No. So you're observing, have you actually, we're not going to go into like legends, okay? Yeah. Go ahead, Carl. Yeah.
Oh, okay. So, like, say you're on a gravity, like, whatever it is, 9.8 meters per second. And so you say gravity everywhere is 9.8 meters per second.
And then it's not everywhere. Okay.
Yeah, because in Canada, there's this place where less.
I think he's talking about a different, like, out of this world. That would be mine. Okay? All right. Hey, it's an unproven statement that is based upon observation. So you're observing, making conjectures. Okay? You use inductive reasoning when you find a pattern. So which did we use earlier? Or what we used earlier today was considered inductive reasoning. Correct?
Yep.
Okay, we looked for patterns. We found those patterns. And we're able to form a conjecture based upon those patterns. Okay. Counterexample, we talked about that. It's just showing that, showing a specific case where a conjecture is false. Okay? If you turn the page, I want you to read about deductive reasoning now, different than inductive, and then about the law of detachment and the law of syllogism. All right, deductive reasoning. Someone give me an example of deductive reasoning. Come on, you're the same people. Give me someone that hasn't participated yet today. Not that I don't like the people participating. Munti, what do you got?
So deductive reasoning would be like something you would like do in science.
Okay.
Where you have to like, you can't just throw something out there. You have to like prove it.
Okay, so it uses facts, definitions, accepted properties, and laws of logic to focus on a logical argument versus building up your conclusion. You're starting, it's like working top down. Okay, you're using laws, things that have already been proven, to work your way down to a conclusion. Okay, yeah.
If this means that and that means this, then this means that.
That's what you're doing with the law of syllogism.
What?
Yeah. Yeah. So in the law of syllogism, you have if hypothesis B, then Q. So if P, then Q. If Q, then R. If those are both true, then you're then saying, well, since this is true with this, and this is true with that, then this is true with that. Okay? So if P, then Q. If Q, then R. So P and R. If P, then R.
Is the law of
Okay.
syllogism always true?
If both those others are true. Yeah. And then you have the law of detachment. It says if the hypothesis and a true conditional statement is true, then the conclusion is also true. So we're going to practice some of this. I want you to take a look at page 42, the bottom. You guys are going to start up on the extra practice. There are 12 problems. I want you to work with your groupies. And I'm going to also hand out your amazingly fun puzzle time for today. This one's a good one too, man. It'll make you chuckle. Okay? Good stuff. Yes?
So for the law of syllogism,
Yes?
would it be like 1 plus 2 or 3?
So minus, whoa.
I'd have to, let me come and talk to you about it. Okay. Get volunteers to come up here to do 1, 2, 3, and 4. Pick one. Come on up. Do them right underneath. Yep. All right, Jeremiah's got 1.
I want
Who's got 2?
I do too.
2. Okay, 2. Who's got 3? 3 down. And 4 is
Bring a pencil, Jeremiah.
No.
I got Jeremiah work. Oh, I have to go first? Should you put that right there?
Number 2.
Good job. There you go.
Multiply
You
by
gotta
negative
describe
1
it.
and then you add 1.
Oh.
Wait. Yeah, where did where did Slow go? I think there's like a typo. That didn't work.
All right.
That was my way.
Ladies and gentlemen, those all would be given half credit if they are correct right now. How come? Yes. They did not describe the pattern. So you got to come back up here and describe the pattern. You can do it. It does say describe the pattern.
Don't sit down. I pulled the chair out.
Gino is
On fire. Yeah, Gino's some extra credit points. You deserve them. No, no. This chair won't back up. Can you not? Can you not? Can you not? Can you not? Back up. Carla, you smell like salt.
Salt. Salt. I need a pencil. God,
I got a pencil. For Jeremiah. Here. You're welcome.
How do I explain this? How does one explain blocks?
Yeah, that's it.
You just add an extra box.
So you add an extra
box.
Well, mine was number 2.
Okay, well then that's your problem.
I want one of these.
Oh.
I can just like project it up.
You
on my
add,
I don't go with
you
that.
add 2, and then
alternate.
alternate.
Okay.
I had it easy. Just write a simple equation. Nope.
Yeah.
Good. That's good enough.
Jeremiah's up. Not you, Patrick.
Haley.
It's not nice.
That's what you get when you have a headbutt in your ear.
Yeah.
Why'd you have an earlobe? I told you freaking not to. Do you ever learn? Dude, this kid. After the teacher said, I'm talking to you. Hey, listen to me, I'm trying to tell a story.
How would you respond?
Garden insects are always polite.
Whoa.
Say you
Okay, go.
subtract.
Let's go, Jeremiah. I'm cheering you on.
Okay.
Ooh, you're good at these.
I know. I have.
Make sure to get it right there. Good. That's exactly what I was thinking. Just the flexibility. Dude, whoa. Ooh, this is gonna be on. Hello, it's Brendan Asher here. Brendan Asher. I'm on YouTube.
Distracting.
Hi, it's Brendan Asher.
All right.
I'm on
Nobody
YouTube.
cares.
Hey, we got to pick up the pace here and move on. I know that you guys are
Jeremiah.
really excited about writing a book here. All right. Oh, look, I got a pencil out of the deal. Score.
Oh, Brendan, your pencil.
All right. Hey, let's wrap up.
Brendan Asher,
Thank you for my pencil.
Thank you.
Mr. McCoy.
Let's go ahead and wrap up today. Number one, you subtract 1 and then subtract 1 more from the previous number you subtracted. We should maybe add there. So you're subtracting 1, then subtracting 2, then subtracting 3, then subtracting 4. Correct, Amundo? Correct. All right. So if you think of it this way, -1, -2, -3, -4. So you keep going. And you'd end up with 5 and -1. So -5 and then -6. Okay, you add 2. Okay? You guys, this one's not right. I think.
Oh, wait, am I right then?
You're taking the next, these are all prime numbers, divisible by 1 in itself. Okay? So I think tomorrow's lesson, we pick up from right here on number 2. Okay? All All right, so that's where we'll pick up tomorrow. You need to finish page 43 of your student journal, which is the next page, right? And the puzzle time I gave you. Oh.
Wait, do you write the letter on the little blank spot, or